Hi students, today you will learn the last lesson on this congruent triangles and proofs unit. It's called Cpctc, say that real fast, and we'll learn what this is. So first we're going to quickly review something we did a couple lessons ago just to make sure we're all on the same page so that we can understand what this new step is for us in our proofs. So this should be review. Feel free to pause it and try to do it on your own first. So if triangle CAT is congruent to triangle DOG, list all of the congruencies. Remember, there's going to be, in congruent triangles, there are 3 pairs of congruent angles, and there are 3 pairs of congruent sides. Remember, your congruent statement is very important. It tells you how the parts correspond. So C corresponds to D. That means those 2 angles are congruent. I'm going to start there. Angle C is congruent to angle D. A corresponds to O, so that means angle A is going to be congruent to angle O. That can be our next congruent statement. And then T corresponds to G, which means angles T and G are also going to be congruent. Okay, so there's the angles. That's always a little bit easier. Now the sides, if the triangles are drawn positioned the same way, like this one looks just like a translation, then the sides are very easy to match up. But if they're not, if they're flipped or they're rotated, look at the angle markings. So notice that between C and A I have a 1 arc and a 2 arc. So this segment CA is going to correspond to its congruent side on the other triangle, also between the 1 arc and 2 arc angles, which would be DO. Okay? Remember, when you name these segments, it doesn't matter the order of the letter. So I could call segment CA or segment AC, and that's congruent to either segment DO or segment OD. Either one is fine. All right, the next sides that are congruent are going to be sides AT and OG, and those are between the 2 and 3 arc angles. So segment AT is congruent to segment OG, and then of course the remaining 2 sides are going to be congruent. Segment CT is congruent to segment DG. So this should be a review. Y'all should feel good about this. Notice there are 6 pairs of congruent parts in 2 congruent triangles. Remember that. So remember, if I can show that all 6 pairs are congruent, I can say the 2 triangles are congruent. However, we have some shortcuts that we've learned about. SSS, SAS, and ASA, we only have to show that we've got 3 congruent parts, or 3 congruent statements, I guess you could say. And that is enough if we're using SSS, SAS, or ASA to show that the triangles are congruent without having to know about the other 3 parts being congruent. We also have HL, and HL is a little bit different. You've got to say that you've got the 2 congruent statements, the H and the L, and then you also have to say that you've got right angles. So that's your other statement, and right angles. Okay, once you see those 3 things, then you can say the triangles are congruent by HL without having to know the other 3 parts that are also congruent. Okay, so here's the deal. If I prove 2 triangles congruent by SSS, SAS, ASA, or HL, then that means that there are 3 additional congruencies that I could then say are also going to be congruent because the triangles are congruent. So let me draw a little picture here, and then we'll talk about what Cpctc is, because that's really what we're going to use in order to state that these additional congruencies exist. So for example, let's just say I had 2 triangles and they're congruent by A, S, A, right? So now they're congruent by ASA. Then I could do another step on my proof, and by Cpctc, which we'll talk about what that represents in just a minute, I can now say, for example, that, oh, these two sides are also congruent, or these two sides also have to be congruent, or these two angles have to also be congruent. So I have the potential to say that these other three pairs of corresponding parts are also congruent because I've already said that the triangles are congruent by ASA. So I'm going to erase all this, and let's talk about, well, what the heck is Cpctc? So Cpctc stands for corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent triangles are congruent. Cpctc, which means if I have congruent triangles, then all of their corresponding parts are going to be congruent, right? All right, so let's see how this works in some proofs. We've got 4 proofs we're going to do. So if you look at this proof setup in example 2, notice the proof statement is not that 2 triangles are congruent, okay? It's that 2 either angles or 2 segments in the triangle or triangles are congruent. We cannot say this until we say that the triangles are congruent. We're going to say this by Cpctc. So that will be the very last line of our proof. And you can even put it down here at the bottom. Cpctc, angle S is congruent to angle T. Now, we have to first prove that these 2 triangles are congruent. So that the part above this line should be what you've already done. You should be used to that. So let's go ahead and go through the steps. First, we're going to mark our givens on our picture. Segment RZ bisects angle TRS. This angle has been bisected by RZ, which means that angles 1 and 2, the resulting 2 half angles, are going to be congruent. All right, we also know that angles 3 and 4 are congruent, so we can show that. All right, so I have 2 pairs of angles that are congruent. I don't have any other givens. I'm thinking that the side between the 2 triangles that they share is also congruent to itself by reflexive property. Therefore, we could use ASA to prove these 2 triangles congruent, and then we can have that next statement at the very bottom. So let's go ahead and go through the steps. So the first thing we're going to do is write our first given. RZ bisects angle TRS. Remember, your reason for writing a given is always given. Now that's not a congruent statement, so I'm going to go ahead and make a congruent statement from that statement, and we were able to say that if that angle was bisected, then that means that angle 1 is congruent to angle 2, and the reason we know that is because of this word bisect here. So we can say for the reason, definition of bisect. Okay, then because this is a congruent statement and it's for angles, I'm going to put an A off to the side. We are done with that given. So we're going to write our next given. Angle 3 is congruent to angle 4. The reason is given. This happens to already be a congruent statement, and it's also an A, so we're done with that given. So remember, we got to have 3 letters. So our last letter is that RZ is congruent to itself. Remember that one? RZ on the top triangle is congruent to RZ on the bottom triangle because they're the same side. So anytime you say something is congruent to itself, it's always going to be reflexive property as your reason. Okay, and this is our third congruent statement. This is actually sides. So I've got the three letters ASA. Now we're able to state that the triangles are congruent. So now you're creating that triangle congruent statement. So this part is new. Be really careful because I'm going to look at these closely. The first triangle can be either the top one or the bottom one, and you can name it however you want. I'm going to name the top triangle. I'm just going to call it RTZ. You have to have the triangle symbol in front. Then you have the congruent statement. Now when I name my bottom triangle, I need to watch the letters, right? Make sure they correspond. So R, to me these look like reflections. So R is going to go with R. T is going to flip down and go with S. And Z goes with itself. So that would be my congruent statement for my triangles. Now that my triangles are congruent, then I can say this last statement that, oh, other parts of the triangle, specifically angles S and T, are also congruent. Okay? Let's try another one. All right, look at that proof statement. Notice that it's not two triangles being proven to be congruent, so we're going to have to prove we have congruent triangles first, and then we could say that one at the bottom. Angle A is congruent to angle B. Remember, your proof statement is always the last statement in your proof, and the reason that we're using now is Cpctc. Okay? So let's go ahead and start our proof. We're going to label our givens on our picture. Segment AB, this guy, this guy bisects segment CD. So it's cutting CD in half, which means the two halves of CD are congruent, CM and MD, all right? The other given is that angle C is congruent to angle D. If you kind of look at these, they kind of look like a rotation, right? These triangles look like they've been rotated. So I've got an A and an S. I got to look carefully at my picture to see what else I see. And oh, I do see, remember, vertical angles are congruent. So that'll be my third A. So by ASA, we're going to prove these triangles congruent. And then by CpCtc, we'll state that angles A and B are also congruent. So let's start with our first given. Segment AB bisects segment CD. Of course, the reason is given. Okay, that's not a congruent statement, but I was able to, from that statement, I was able to say that segment CM, which is half of CD, is congruent to segment MD, which is the other half of CD, because CD was bisected. And the reason I know that is because of this word bisect. So the reason is going to be definition of bisect. Okay, remember when you're bisecting, look at what's after the word bisect. That'll tell you what you're bisecting. If you're bisecting a segment, you're going to have congruent segments. If you're bisecting an angle, you're going to have congruent angles. All right, so this is a congruent statement, and it's sides that are congruent. So I am done with that given. Next given, angle C is congruent to angle D. Okay, the reason is given. This is a congruent statement, and that's an A, so I'm done with that. All right, the third letter that we saw were those vertical angles. Because they both have vertex M, I've got to use three letters to name them. So the angle M on the left, I could call angle AMC or CMA. Oops, use my other color. And then the angle M on the right, I could call either angle DMB or BMD. The reason we know that they're congruent, that we can state this, is because they're vertical angles, and vertical angles are congruent. Okay, so that is our third congruent statement. Those are angles, so I'm going to put an A. Now I can see I've got my three letters for ASA. Now I need to write my triangle congruent statement. So start with one triangle. If I start with the triangle on the left, I might call it triangle AMC or some other combination of those three letters. And then the triangle on the right, I need to be very careful that my letters correspond. Now I kind of said that this looks like a rotation. So it looks like the A is going to rotate to the B. The M just stays on itself, and then the C rotates to the D. Okay? So because I can now say that these triangles are congruent by ASA, I can then go a step further, and by Cpctc, corresponding parts of congruent triangles are congruent, we can say that angle A is also congruent to angle B. All right, we got two more. All right, we're showing this time in our proof statement that we've got congruent segments. Again, that's not a triangle congruent statement, so we're going to use Cpctc to state that after we've proven the triangle is congruent. So you have to prove the triangle is congruent first. So let's go ahead and mark our picture. M is the midpoint of AB, so that means the two halves on either side of M are congruent. So segment AM and segment MB are congruent. It also says angles 1 and 2 are congruent, and angles 3 and angles 4 are congruent. So we already have our ASA. Let's go ahead and start. Our first given, M is the midpoint of AB, and of course that's a given. That's not a congruent statement, but we were able to determine that it's two halves, AB's two halves, which is that's ugly, which is AM, is congruent to the other half, which is segment MB. And we know that those are congruent because, look at the word above, midpoint, definition of midpoint. Hopefully by now you're starting to kind of get the hang of these proofs. This is a congruent statement. It is an S. Let's go to our next given. So we're done with that one. Our next given is that angle 1 is congruent to angle 2. That's a given. That happens to also be a congruent statement. And those are angles, so I'm going to put an A. Now we're ready to go to the last given. Angle 3 is congruent to angle 4. And of course that's a given. This is also a congruent statement, lucky us, and it's our last A. So now we have ASA. We just need to write our triangle congruent statement. So let's start maybe with the triangle on the left. You can call it any combination of the letters C, A, and M. I'm going to do CAM. And then the triangle on the right, we got to be real careful the order that we put those letters in. To me, it looks like a reflection over this line right here. So A flips over to B, C flips over to D, and M stays upon itself. So C goes with D, A goes with B, and M stays with itself. So these two triangles are congruent by ASA, so we can therefore, by Cpctc, also state that segment AC is congruent to segment BD. All right, the very last example, here it is. You can go ahead and write it down. We're going to do this one in class because we are running out of time. See you soon.